Well, welcome to this online revision session for AQA FP4, in which we will be looking at the June 2010 question 8 on matrices and transformations. Well, on the face of it, a relatively straightforward question. We're given a matrix which represents the transformation, which is a composition of, in either order, an enlargement with a scale factor k, followed by a shear which has a fixed line which passes through the origin. And we have to show that the scale factor of the enlargement is 24 and also find the Cartesian equation. Well, how are we going to approach this one? Well, the first part, finding the scale factor. Now we know there is a relationship between the determinant and the area scale factor. So we know the area scale factor of the composite transformation by working out the determinant of this matrix. We know the determinant of a shear is 1, and we know that the determinant of the enlargement is k squared. So we know that k squared times 1 must equal the determinant of this matrix. So in other words, we know that k squared will equal the determinant, which is going to be 36 times 12 minus 16 times negative 9, which gives us an answer which will equal 576. So k must be equal to 24. So let's find that. So I think we probably need to put a line in something like the determinant of this matrix equals the determinant of E times the determinant of S. So if we call this matrix here W, let's say, then we can say that the determinant of W equals the determinant of E times the determinant of S. Okay, so K will equal 24. And then we've got to find the Cartesian equation of the invariant line for the shear. Well, firstly we need the shear matrix. Well, if we know that K is 24, we know that the enlargement matrix is going to be 24 times 1, 0, 0, 1, and we know that S times E must equal W, so S must equal 1/24 of W. So if that's the case, if we divide that by 24, we get a half. 9 over 24, which is, no, negative 9 over 24, which is negative 3 over 8. And 16 over 24 is 2/3. And 36 over 24 is 3 over 2. So there we have our matrix for S. So now to find the invariant line, or the line of points which are invariant, we need to multiply any point xy by this matrix, and we should get xy as the answer. So we know that a half, negative 3 over 8, 2/3, 3 over 2, multiplied by xy has to equal xy, So if we multiply the left hand side, we get the fact that a half x plus 2/3 of y must equal x, and we get minus 3/8 of x plus 3/2 y must equal y. So simplifying the first one, if we take the half x from both sides, we get the fact that 2/3 of y equals a half of x, and on the second one, if we take the 3/2, we're going to get 3/8y equals a half of y. Basically, those are the same equations because they're saying that x must therefore equal 4/3 y, or y equals 3/4 of x. And the bottom one, if you multiply by 8/3, sorry, somewhere along the line there I've lost an x, haven't I? My apologies, that's an x in there, it was 3/8 of x. Yep. So if I double both sides, I will get y is, again, 6/8, or 3/4 of x. Okay, so where do we get our marks then for our 7 marks? Well, a statement of attempting to find this determinant. I'll give you 1 mark and an accuracy mark for actually obtaining the value of k. Then realising the fact that the shear is 1/24 of w will get you 1 mark. And then from there, your method then for finding the invariant, the set of invariant points, you get 1 mark for that statement and an accuracy mark for obtaining the correct expressions here, and then a method mark for working through to the final statement of the correct Cartesian equation for L. Well, hopefully you found that solution useful. For more support for your maths studies, please go to the Further Maths Support Programme website.